Okay, y'all, we are working on inequalities today. So, for inequalities, some things that we're going to look at is just how to shade it and how to determine which line to use. Okay, so to get started, we have some important information here. So, anytime I want to start over here with the kinds of lines that we're looking for. Okay, so anytime we have an inequality, it means that we have more than one solution. And so something that I like to use to remember is solution, solid, and shaded. If you can remember that those words go together, you'll be able to master inequalities. So when we're talking about a solid line, we're talking about something that looks like this, it's completely connected. We always know that inequalities use a solid line when they have this line underneath. Okay, so on the flip side, when we have a dotted line, okay, this dotted line is when we have inequalities that have no line underneath them. They're not inclusive, and so the line will look like this. It'll be broken or dotted is what we call that. Okay, and so over here, one other thing that we know about inequalities is that we can either shade up or shade down. So the trick I'm going to show you will only work if your line is in slope-intercept form. So y equals mx plus b. Now what the trick is that if you have a sign that says greater than or equal to or greater than, you know that those are going to be shaded up because it makes the word up if you put a U and a line right there, and that means you're going to start at the line and you're going to shade up. So all the solutions will be above the line. Okay, in the same way for shading down, again, it only works if it's in slope-intercept form, but in order to shade down, if you have something that looks like this, where your less than sign makes the word down, you're going to shade from the line down. So all of our solutions are going to be less than where the line is. Okay, so those are just some important things to remember. We're going to jump in with example number 1. Okay, so it says which inequality represents the graph below. So we're looking to see which of these equations is the same as the graph. What I like to start with when I'm looking at these is I want to take a look at what kind of line do I have. Okay, and this line, if I look back up at my notes, is a dotted line. Okay, it's broken or it's dotted, which means that the sign is going to be this or this. There's not going to be a line underneath it because the line is dotted. So first thing I want to do is go ahead and look at my answer choices and find which signs would be a broken or dotted line. And what I notice is that A would not be correct because A looks like this. It looks like the solid line here because it has a line underneath it. Okay, same for B would not be correct for the same reason. So I'm down to C and D. Alright, C and D. So the thing that I noticed that are different about these two answer choices, the only thing that's different is this one says y is greater than, this one says y is less than. Okay, if I want to use my trick that I mentioned at the beginning, I'm going to check and see, is this, first of all, is this in slope-intercept form? And this is in slope-intercept, both of these, because y is all by itself. So I can take a look and see, is this shaded, is this where the solutions are, is it shaded up or is it shaded down? And it is actually shaded down. Okay, so I'm looking for this sign that looks like less than or makes a D. Alright, and from these, C gonna be up and D is gonna be down or less than. So my answer would be D. Now, if you get to this point in the question and the answer is not in slope-intercept form, I'm going to show you another way that you could check this answer choice. So one way we can check an answer choice is by finding a point that, remember, is in the shaded area or where there are solutions. Okay, my point that I like to pick most often is 0, 0. Okay, I know that that is a solution because it's in the shaded area. Okay, so what I'm going to do now is I'm going to take a look and I'm going to plug in my x and y to each of these inequalities to see if they give me a true or a false. So first I have 0, 6 minus 2 times 0. And then the same is true for D. Okay, the only difference again is the sign. So I'm going to go over to my calculator, show you how I would test these points. So I add calculator, and I'm going to go ahead and try C first. And I'm going to do 0 is not equal to, control equal is greater than 6 minus 2 times 0, and that is false. Alright, so that is false. So again, that tells us that this is that 0, 0 would not be a solution for this. So once again, that's how we could check and see if D is our answer. Alright, we'll do something similar on example number 2. So again, which inequality, let's read this question, which inequality represents the graph below? So I'm looking to see which of these is the same as this graph. So looking first at back at my notes, I want to look and see what kind of line is this? Well, this is a solid line, so I'm looking for the inequalities that have a line underneath them. If they do not have a line underneath them, I can eliminate them as an answer choice. So I'm going to eliminate A and B because those signs are not correct. Okay. Now I have two options. I have C and I have D. So I'm going to use the test point that I used over in example 1 to show you this one. So again, I'm looking in the shaded area for a solution, and I'm going to pick 0, 0. Now, if it is a solution, then the calculator is going to tell me that that equation or that inequality is true. So I'm going to write out C. Replace y with 0, greater than or equal to negative 2 times 0 plus 4. And I'm also going to try D and see which one of these tells us that 0, 0 is a solution. So again, we do this over here in our calculator. I'm going to start with C. 0 is greater than or equal to negative 2 times 0 plus 4. That tells me false, so that one's probably not the answer. I'm going to go ahead and write false on my paper. And then I'm going to try D. Is less than or equal to, oops, control equal is less than or equal to 8. And that one tells me true. Therefore, D is my answer because true means it is a solution. Alright, last kind of question that you're going to see is something like example 3. It says, which ordered pair is in the solution set of y is less than or equal to 3x plus 1? So remember, when we're looking for a solution, we're looking for something that is true and it's in the shaded area. Okay, so one way that I could try this question is I can use my inequality and replace my solution in the inequality to see if it's true or false. So I'm going to go ahead and instead of y, I'm going to write 1, because that's my y value, is less than or equal to 3 times x plus 1. And I'm going to try that in the calculator and see if it gives me true or false. So I'm going to go ahead and write out all of these. 1/2, 3 times negative 2, 2, 3 times 0, okay, so what I just did was I went ahead and I plugged in my x where the x is in the equation. Okay, so I'm substituting my x and y into the equation where the x and the y are. Now I can use my calculator to check to see if these are true or false. So I'm going to start with A right here, and I'm going to type that in. 1 is less than or equal to 3 times negative 1 plus 1. Okay, that tells me false, so I'm going to write to the side an F. So that is not a solution, not an ordered pair. That is a solution for me. I'm going to go ahead and try the next one. Try B. Negative 2 plus 1. That one is also false. So B is not the correct answer. I'm going to try again with C. Plus 1. Enter. That one tells me that it is also false. Alright, and let's try the last one. So this one must be our answer, but I'm going to check it in the calculator. Times 5 plus 1. Sure enough, that one gives us true, which means that true is a solution. So D is our correct answer. Okay, so you can use these strategies for the next couple of questions and the questions that you'll find on your ACP. So good luck.